Hello guys, welcome back to Maison African Motives. Still working on mathematics and for that is on differential calculus. So in this platform, we shall have a continuation working on the chain rule or the function of a function. That is, we need to understand where exactly do we apply such type, where do we actually have this rule or application of this method of the chain rule or the function of a function. So if we can take it from function of a function, maybe we can understand this much better to say we have got a function which is taken from another function. That is, we are creating a function from another function. Let us take an example of a normal basic cos or a trig function. Let us just say we have got let us just say let's have, okay, let me just have it as an equation so that we understand what I'm trying to say here. We are given y is equal to the cosine of x squared plus 2x plus 1, like this. Okay, if you are to take this into consideration, you see that we have got something that is different from what we are used to on our cosine function. We used to have just a normal cos, which is given as cosine of x, or we can be given y is equal to cosine of 7x. These were normal things that we're having before, where I say the derivative of a cos is going to change to a negative sign. Dy dx it's going to be negative sine of x. If we are given now having a number here, which is a linear, take note, this is just a linear expression that you're given, where we are going to have this as negative 7 sine 7x. But if you take here, we are not going to have that in a basic way like that. Okay, which is where we can introduce to say this part here, it's a certain function which is the same as the 7x, but because it was a linear part, we could have just worked direct, which is the same thing that we can do here, but we are working it as function of a function. How can we make it this a function? Okay, check what we have here. If you are to create a certain function here, we can just let this expression that has got x, because we have got x here, so you can let this to be equal to u, so you can introduce u in this case. This is the major part that we need to understand. So we can just say let our u in this case be equal to x squared plus 2x plus 1. So I want you to see what is going to happen. If we say u is representing x squared plus 2x plus 1, it means in place of this expression that you're given here, where we've got x squared plus 2x plus 1, we are going to have this as y is equal to the cosine of u. All this whole part is now left with u. So that means we are now having two things. We are now having an expression or an equation that you can have y in terms of u. On this part, we are having u in terms of x. If you check on this part here, this is u in terms, a function of u in terms of x. Here, y in terms of u. But we want to connect these two functions that we have so that they give us what we refer to as dy dx, a derivative of y with respect to x. How is that possible? That is where we have got our formula that is referred to as dy du. In this case, from this part, we are going to have dy du, that is the derivative of y with respect to u, times the derivative of u with respect to x, the derivative of u with respect to x, which is, in this case, if you check, if you cancel du, because it's a multiplication, you remain with dy dx. So that means to obtain dy dx from this formula, we must have a function of u from the function of x that we had before. So this is what we are referring to as the chain rule, which you are also given in your formula sheet. That is for mathematics and for, we are going to have this given. So this is what we refer to as our chain rule formula or function of a function formula, meaning to say from y, we are going to find the derivative of y with respect to u. That is, in this case, if you find the derivative of y with respect to u, in this case, it's a cos, and we said a cos changes to a negative sign. So this will be negative sine u. I want you to see what is going to happen here. from u, they are saying you must find a derivative of u with respect to x, meaning to say we shall have du dx from this side. So basic from our standard part, we talked about this. So this is going to be 2x plus 2x is a linear expression. So this is going to give us 2. 1 is a constant. Remember, we said the derivative of a constant is a 0. So meaning to say these are the ones that we are going to substitute into the formula du dx, this part, and the part of dy du in this part. That is the one that we need into the formula now. So let us take this into the formula and see what you're going to have at the end. We are saying from our formula of the chain rule, it states that the derivative of y with respect to x is going to be determined from dy du in this case, which is dy du, this part that is a negative sine of u, times du dx, that is the derivative of u with respect to x. Here du dx is 2x plus 2. So we're going to have 2x plus 2 in this case. Now, if we are to combine this part, let's say we are to combine this part, we are going to have this as dy dx is equivalent to, this is sine u. So we can just start with the algebraic part here, the algebraic part, which is going to give us a negative. In this case, this is negative that we have. So we are going to have negative into 2x plus 2 like this. The sine of u, the sine of u. But if we consider this as our final answer, this will be wrong. Why? It's a derivative of y with respect to x. Meaning to say our answer is supposed to be of x throughout. But here, if you check, there is a u. So we are supposed to get rid of this u that we have, in write this in terms of x. It must be in terms of x. So what are we going to do? We get back to where we introduced let u be equal to, we introduced u this part. So we're going to take that part in place of this u that we have here. So meaning to say our final answer now can be written as therefore, so we shall have this one. All right, so we just need to substitute that dy, that u there. So therefore, our dy dx is going to be given as negative into 2x plus 2, the sine of u in this case, which is the sine of u that is from the u that we got here. Remember, we said u is equal to x squared plus x plus 2x plus 1. So this is what you're going to have. So we substitute in place of u, we are going to have x squared plus 2x plus 1 like this. As we can see, we are now having a derivative of y with respect to x. Everything on our final answer is in terms of x. So this is how we apply our chain rule. We are taking the formula, which is our chain rule in this case. So what we need is from the functions that you are given, or from the function that you're given here, the part that has got x, the part that has got a x is the one that you let u be equal to. The part that has got x, from the complicated trig that you have, from the complicated exponent, from the complicated logarithm, whatever type of an expression that you're given, that is how you simply apply your chain rule. So we've got so many questions that we shall consider from our past exam papers, some from our textbooks, so that we can have into consideration how to exactly apply our chain rule. For example, let us say we are given y, which is equal to 2x squared minus 1 in this case, and this everything is raised to the exponent of 2, and we are asked to apply or to use function of a function. So for our syllabus for mathematics N4, you'll be told to use function of a function method. They will actually direct you to the method to use. So when you're directed to use the function of a function, like I said, we need to apply our formula. We state that the dy dx, which you are given on your formula sheet, is dy du times du dx. So this is the formula that we are going to apply. So that means we need to find u in this case so that we can have a derivative of u with respect. So as you can see, u must have x. So u, it's a function that must have x. Which part? So we can let this part here that has got x to be our u in this case. So we're going to let our u to be equal to this part that has got x, which is 2x squared minus 1. But as we see that once we've got u, we need du dx from there. So definitely let us find our du dx. So the derivative of u with respect to x is going to give us, now we can find the derivative. So 2 times 2, that is going to be 4x. We subtract 1 here, so it's going to be 1, which is 4x. The derivative of -1 is going to give us a 0 because it's a constant, this one. So that's a 0 there. All right, so that is our du dx. But as we said that once we say let u be equal to this, it means we are going to rewrite y as u in place of this whole part here. We are now having at is as u. So this is now as u to the exponent of 2, where you can find the derivative of y with respect to u. As you can see here, it's y with respect to u. So the derivative of y with respect to u, we are going to drop our exponent here, which is going to be 2u. We subtract 1. So that will remain as 2u. So these are the ones that we need in our final answer. So we are going to substitute now to say the derivative of y with respect to x is equal to, that is dy du. In this case, we've got our dy du here, which is 2u. So we are going to have 2u times the derivative of u with respect to x. That is the derivative of u with respect to x, which is 4x. So that's it. We can multiply, in this case, 2 times 4x. In this case, we can just have this. Remember, our u, it's an expression in terms of x also. So we can just multiply 2 times 4x, which is going to give us 8x times u in this case. All right, so let us substitute our u. So that's 8x times u in this case is the part that we introduced here, where we said let u be equal to 2x squared minus 1. So in place of that, we are going to substitute our u as 2x squared minus 1. So as we can see, our derivative of y is actually in terms of x. We are having x on our final answer. So this is how we apply our chain rule, guys. So many questions that you can have into consideration. All you need is to understand your formulas and also your basic derivatives, as we talked about these derivatives before. All right, so let us have another question again from our chain rule. We are given y is equal to the square root of sec x. Still applying the chain rule. So how is it possible? All right, remember from our exponents, the square root is same as to the exponent of a half. So this is sec x to the exponent of a half, like this. So as long as you're dealing with certain exponents, we have given f of x, like it's f of x like this to the exponent of n. This is the best way where we can apply our chain rule, where a function is being raised to a certain function, or a function is inside a certain function, like that part that I introduced, like we're having cos f of x like this, where f of x is another function which is not a linear function. Then we can apply chain rule direct or function of a function. So these are the typical examples that you must have into consideration or in mind. All right, so as we saw from our formula, guys, if we are to write down our formula, we saw that dy dx is equal to dy du times du dx. So that means in this case, we need to introduce our u. In this case, we need to have our u in this case. So we are going to just let our u to be equal to the part that is, remember I said u goes with x. U always goes with x. So the part that has got x, it's sec x. So u is going to be equal to sec x. So if u is equal to sec x, it simply means we are going to have y now written as, in place of this part that has got sec x, now it is a u. So this will be u to the exponent of a half. Once you've got your u and your y to with part of u, then you can find your derivative. You need dy du, you need du dx. So from this part, we are going to find the derivatives as for our formula. So that is du dx is equal to, remember, from your formula sheet you are given, the derivative of sec is going to give us sec x tan x. All right. Then we move on to u, the derivative of y with respect to u. In this case, this is an exponent, so we drop the exponent. That's 1 times a half, which is half u. So this is a u to the exponent of, remember, we subtract a 1 on our exponent. So it's a half minus a 1, which is going to give us a minus half in this case. So this is what you're obtaining from our u, which you can simplify further to say this is going to give us 1 over 2. That's u to the exponent of a half is same as u to the exponent of a negative half is same as 1 over to the exponent of a positive half, which is same as the square root of, we are referring to u, not to 2. So 2 square root of u. So this is what you're going to have. We are going to obtain 1 over 2 square root of u in this case. All right, so let us bring this back to our formula. That is the derivative of y with respect to x is going to be, we substitute now our dy du, which is the derivative of y with respect to u, which is this part that we had here. So that is where we have our dy du in this case, which we got as 1 over 2 square root of u. So we are going to obtain this as 1 over 2 square root of u times the derivative of u with respect to x, the derivative of u with respect to x, which is this part, the derivative of u with respect to x, we got sec x tan x. So this is the one that you're going to use. So we're going to have sec x tan of x. But this is a fraction. Remember, every whole number as a fraction can be written as over 1. So that means we can simplify further from this part here. We can be able to multiply. Simply means you're multiplying the numerator to the numerator. So we are going to have sec x tan x, everything over 2 square root of u. So this is going to be 2 square root of u. But remember what I said. Your final answer always is supposed to be in terms of x, because we are having a derivative with respect to x. So we need to substitute whatever that is represented in terms of u here in terms of x. So we go back to our introduction where we introduced u. In this case, we introduced the u here, and we said our u is equal to sec x. So it means where there is a u, we are going to substitute with sec x in this case. All right, so there we have on our final answer, in place of u in this case here, we've got square root of u, so it's going to be square root of sec x in this case. All right, so therefore that is going to be our final answer in this case for the derivative of u with respect to x. So that is a function of a function, or the application of the chain rule in this case. All what you need is to understand the steps that you're given, following of the steps that you're given. That is the most important part. All right, let us see the other part of our question that you're given in this case, where we can be given even a square root of a algebraic expression. All right, so we can even be given the square root of an algebraic expression. Like for an example, you're given y is equal to the square root of 5x plus 1. So it can be an algebraic expression, just like the previous part where we had a trig function, a trigonometric function. So it can be an algebraic expression with 5x, or it can be 10x, it can be whatever part. So the simple part that we are having is, how are we going to write the square root? That is the most important part. So the square root, like I said, from the exponent of a half. So this is going to be given as y is equal to. So we are going to have y being equal to the whole part of 5x plus 1, everything being raised to the exponent of a half. So our u cannot be a half. We do not have x there. U is supposed to be a function that has got x. So meaning to say we are supposed to think of this part inside the bracket where we are given 5x plus 1. The whole of this part inside, this one, it's a single expression. So that expression that we have is supposed to be to combined. It's inside a bracket. Whenever you've got a bracket, you take that as a single term, just like a single term. That is how you play around these typical questions. So that means here, we are going to let our u to be equal to 5x plus 1. The moment we let u to be equal to 5x plus 1, that means I'm now rewriting my equation as y is equal to, so you're now having y is equal to, this whole part is now represented by u, so it is going to be u to the exponent of a half. So that's it. We find your derivatives as we saw from our formula that we are going to have the derivative of y with respect to x being equal to the derivative of y with respect to u times the derivative of u with respect to x in this case. So that means we can play around in this case y with respect to x, u with respect to x here, the derivative of u with respect to x, that is 5x, it's a linear, so we are going to take 5. Constant here, 1 is a constant, so that's a 0. So that means we are going to remain with 5 there. The derivative of y with respect to u in this case, we drop our exponent here, so it is going to be a half. We subtract 1 on our exponent, so that's u to the exponent of negative half, just like the previous part. We are going to have 1 over 2 u to the exponent of a half. To remove the negative here is going to be 1 over. So it's like you're actually multiplying 1 over 2 like this. You are multiplying 1 over 2 times 1 over u to the exponent of a half. So that is what is happening. So 1 times 1, which is 1, 2 times this, which is going to be 2u to the exponent of a half. But as we saw that to the exponent of a half was taken from the square root. From the square root, we have a half. So it's now a vice versa. It's now a reverse. We are reversing back to this part. So it is going to be 1 over 2 square root of u in this case. So this is our dy du from y with respect to u. And we can just substitute into our formula because we've got everything in this case. So that means here we are going to have the derivative of y with respect to x. With respect to x. That is the most important part that we have. So it's dy du, which is 1 over. So we obtained 1 over 2 square root of u times the derivative of u with respect to x. This is the part that we got 5. So we are going to multiply 5. Like I said, 5 is a whole number, this one. The moment you just write it as a fraction, it's now over 1. So that means you can multiply the numerator to the numerator, the denominator to the denominator. So that means at the end, we are going to have this. Before substituting your u, you can just simplify your fraction so that you properly understand what you are writing there. So that is 1 times 5, which is going to be 5, everything over 1 times 2 square root of u. We are going to obtain 2 square root of u, which is, if you check, it's not in terms of x, but it must be in terms of x. Our answer is supposed to have x. So we go back now to the introduction of u that we had. We said u is replacing 5x plus 1. So it means in place of u, we are going to substitute our 5x plus 1. So that is what you're going to have here. In place of u, we are going to have our derivative, as therefore the derivative of y with respect to x is going to be 5 over 2 square root of 5x plus 1 in place of u. So remember, we said our u is represented by 5x plus 1. So like this, guys, you've got your final answer. So that is how you play around these typical questions. So it can be a trigonometric function, a logarithmic function, whatever type of a function that you're given. That's the same approach that you're going to apply throughout and throughout. Just like this part, you have got y is equal to tan into bracket x to the exponent of 5 minus 7x. If you check the first question that I introduced, it was like this. That was having a cosine. So the idea, like I said, it is not going to change. We are still going to find u in this case, which is the part that has got x. U always goes with x. So if you don't understand, write your formula first. Dy dx is supposed to give us dy du times du dx. Remember, this is function of a function. So that means in this case, if you are to check here, we are saying du and du cancel. So what you see, y and u and x. So that is the most important part. U goes with x, y goes with u. If you can understand this part, you're done. So which part is going to be our u? The part that has got x, u and x. So that is the part that has got x. So let our u be equal to x to the exponent of 5 minus 7x. That means we are going to rewrite now this part as y is equal to. So y is now equal to tan this part represented with u. This whole part is now u. So this is going to be tan u in this case. So that is going to be our y in this case. Once we've got this part, therefore let us differentiate u with respect to x. So the derivative of u with respect to x is going to be, we drop our exponent. This is 1, so it's 5 times 1, which is going to be 5x. We subtract 1 here, so it's going to be 4. Negative 7x, this is a linear expression, so you're going to obtain negative 7. So if you don't understand these derivatives, please make sure that you watch the introduction part on the standard form derivative so that at least you know what is happening here. All right, so we've got dy du, in this case tan. Remember I said tan gives us sec squared, so this will be sec squared u. From your formula sheet also you're given the derivative of tan x, but this is u, so you just put a u in place of x. All right, so that is what you're going to obtain from our introduction of u and the derivatives. So now we can substitute into our formula. The derivative of y with respect to x is equal to, that is dy du in this case, which is our dy du from this part gave us sec squared. So we are going to obtain sec squared u times du dx, which is the derivative of u with respect to x. Here we obtained 5x to the exponent of 4 minus 7. So this is what you're going to have at the end. So now with the simplification part that you're going to have, we can substitute our u in this case. Remember we said u is equal to, that was x to the exponent of 5 minus 7x. So that is what you're going to substitute here in place of u. So we can just start maybe by rearranging. We can start with the algebraic, then follow with the trig function. So dy dx is going to be 5x to the exponent of 4 minus 7. You can even write this in a bracket like this. Then we are going to have sec squared u in this case. So what I'm saying is, in place of u now, we are going to take our u, which is x to the exponent of 5 minus 7x. So this is x to the exponent of 5 minus 7x like this, having our squared on the sec. So this is how we can answer a lot of questions, different types of questions, as long we can create a certain function from the one that you're given, then we can apply our formula. So that is what you have. So you can have different types, and don't panic with the terms that you're given. Some of us, we just panic because of the given terms. Like this one, we are given y is equal to 4x minus I, like this, to the exponent of 5, and you're asked to apply the chain rule or the function of a function to find the derivative. So as we are not even going away from our, we simply have our formula first, that the derivative of y with respect to x must give us the derivative of y with respect to u times the derivative of u with respect to x. So that means we need to have u in this. There must be a u with respect to x, and the part that has got x is this part. We can't take 5 here, an exponent, because we do not have x there. If it is an exponent that has got x, then we can use it, but it does not have x. So that's why we are saying we can't have this as our u. U is supposed to go with x, like I said before. So that means our u is going to be 4x minus I, like this. Therefore, it means I'm going to rewrite everything. Y now is equal to, in place of this whole part, we are now having it as a u. So y now is equivalent to this part, like I said, having a u. So it's going to be y is equal to u to the exponent of 5. So that's u to the exponent of 5. So from u and x, what do we need from u and x? We need the derivative now of u with respect to x. So that is 4x is going to give us 4. This is a linear expression, a linear term. Then I, we do not have x on I there. So that means it's a constant. And we know that the derivative of a constant gives us a 0. So this one is going to give us a 0. So it's nothing there. That's dy du. In this case, we are going to drop our exponent 5 times 1, which is 5u to the exponent. Remember, we subtract 1 on our exponent. So this will be a 4. With these guys, we can substitute back our formula into our formula, the values that we obtained, dy du, which is 5u to the exponent of 4 times du dx, which is 4 in this case. So here we can simply multiply the numbers together, 5 and 4, which is 20u to the exponent of 4. But it's in terms of u now. we need it to be in terms of x, and our x is or our u in this case in terms of x, it's 4x minus I. So we are going to have 20 times 4x minus I like this, which is u to the exponent of 4. So that's everything to the exponent of a 4. So this is how we can answer this type of a question. So if we've got any other questions that you might consider from our past exam papers, let us know them on the comment section so that we can work with those questions as much as we can in our revisions. Let us just see this one, which is an exponent with a cos. All right, we've got y is equal to e to the exponent of cos x in this case. How can we apply the same concept? How can we use the same concept, the same formula, the same rules that we had? All right, so if you check here, we can, if we check e, we can't say this can be equal to a u. So because we said u must contain x. So it means now we are limited on this part. We are focusing on the exponent. The exponent this time is the one that has got x. Our exponent is the one that has got x in this case. So that means that is where we are going to play around. So we're going to have our u as the cosine of x like this. The moment that we've got our u as the cosine of x, it means this whole part now is going to change. We shall have it written as y is equal to e to the exponent. This whole part is represented with u. So it is going to be e to the exponent of u like this. Once you are given your u and your y, then you can find your derivative. Like I said, guys, I think this one we are now used it to dy dx is going to give us dy du times the derivative of u with respect to x. So that means here we are going to find the derivative of u with respect to x, which is we are dealing with a cosine. Remember, cos you are given from your formula sheet. Cos changes to a negative sign. So this will be a negative sine x in this case. So we are going to have negative sine x. So now you can, as long you've got this, you can find your derivative separately. Okay, so let us check what we have got on the y with e in this case. So we've got y with respect to you. Remember, an exponent, if you're dealing with exponential function, we talked about this in our previous class, okay, where I said that, let me just have it aside here. I was saying this can be taken from a, you remember from your formula sheet, it's given a to the exponent of f of x, which in this case, if we do not have, like, it's just a u, guys. So this, we just take it as a to the exponent of x. If it is a number raised to the exponent, we are going to have this as the derivative of this is going to be a to the exponent of x times ln of a. If there is a constant, then you are going to multiply with the constant, which we do not have in this case. We do not have the constant, so we're just focusing on this part. So as you can see, that means the derivative here of y with respect to u is going to be this part to the exponent of, which is e to the exponent of u. So that's e to the exponent of u times the ln of a, which is the ln of the base. Our base, it's e in this case, and ln of e, it's a 1. So meaning to say we are going to just remain with e to the exponent of u. So that's dy du is just going to remain as e to the exponent of a u in this case. All right, so let us substitute now into our formula from our chain rule, formula. Now we are saying dy dx is equal to dy du, that is dy du, this part, that is the derivative of y with respect to u, this part, which is e to the exponent of u, times du dx, the derivative of u with respect to x, which we got negative sine x. So all you need is now to substitute so that we remain with x on our final answer. So that means the derivative of y with respect to x is going to be e to the exponent of our u. We said u is cos x. So that will be e to the exponent of cos x times negative sine x. So we can just finalize our answer. In this case, that means, therefore, the derivative of y with respect to x is going to be negative. This is same as 1. So it's 1 times negative which is negative. We can start with sine, then we end with exponent. We can start with the exponent, end with sine. This one does not matter at all. So that will be negative e to the exponent of cosine x times the sine of x in this case. All right, so like I said, on your final answer, when you're given an exponent and a trig function, you can even start writing your answer with trig, you end up with an exponent, or you can start with an exponent, end up with a trig. But what is important is that part that we've been talking about, the introduction of u in this case. It was on the exponent, which is different from other part. Yes, it can be like that. It can be on the exponent like this, or then what you need is to look. The u is supposed to be a term that has got x, or an expression that has got x. So you're considering where there is x, that is where our u is supposed to be affected. Okay, let us check the last part of the question from these tutorials. Shall we have another one? There are so many questions that you can have from our past exam papers, so we shall bring others as we move on. For now, let us just have this as our last question, where we are given y is equal to the ln of ln x. How is it possible? Still, we are on the chain rule. Still, we are on the application of the function of a function. The part that has got x. If you check, this is same as we've got ln 5. So the 5 that was affecting ln is now taken as a ln again. So this does not stop this to operate as a normal ln. It's still going to be the normal ln that we know, but it's being affected to another ln. So which one has got x? This one has got no x. It's this part that has got the inner part of a function, which is ln x. This is the one that has got x. So it's the one that we are going to consider as our u in this case. Remember, I said u is the part that has got x. All right. So we are going to say our u in this case. All right. So let me just write it aside here. So we are going to have our u is the ln of x, the part that has got x, this one. All right. So if this represents our u as we wrote here to say our u is going to be represented with ln x. All right. How are we going to have our final presentation of y in this case? If you check, y now is going to be written as ln, this ln first one, the first ln like this. But this ln x is now represented with the u like this. So it's now ln u like this. Of which ln u, guys, is just ln u. Okay, so this one, there's no need for us even opening a bracket, just ln u like that. Okay, so that is what we have. Remember the derivative of ln, we talked about this also in your formula sheet. It's ln x is 1 over x. So meaning to say the derivative of u with respect to x is going to give us 1 over x. The same thing here. The derivative of y with respect to u, since it is a ln, it is going to give us 1 over u. If we can have 1 over x for ln x, then it means we've got 1 over u again if it is ln u, because it's just one and the same thing. These are linear expressions. U is a linear expression just as x. So if we have got 1 over x, therefore for u, it is going to be 1 over u. So that's it. Let us save it on our formula. Remember, our formula states that dy dx is going to give us from dy du. So we are going to obtain this from dy du times du dx. So we can substitute into our formula. Thus, dy dx is going to be equal to dy du in this case. That is the derivative of y with respect to u, which is 1 over u. So we're going to have it as 1 over u times du dx, the derivative of u with respect to x, which gives us 1 over x in this case. So you can substitute our u in this case. Remember, u is represented with the ln x. U is ln x. So that means in place of u, we are going to write this as ln x. All right. So let us substitute. In place of u, we are going to put ln x. That's dy dx is equal to 1 over u, which is ln x, times 1 over x like this. So what you have now, you can finalize, because everything that you have here is in terms of x. If you check here, we're limited to u. So now we have got x. So you can combine everything now on your final answer. That is the derivative of y with respect to x is going to give us, remember like this, you can multiply the numerator to the numerator. That's 1 times 1, which is going to be 1 over ln x times x. This can be given as x ln x. Never be tempted to write this as ln x squared. This is not x times x like this. No, the x multiplies the number that is here. So it's x times 1, which is x. So it's going to be x ln x like that. Okay, so that is the derivative of y with respect to x that you're going to obtain from this part. So as you can see, guys, what is important is having the u from the function of x, from the function that has got x. Then from there, we rewrite y in terms of the u that we introduced, because it let u be equal to. So it means y x is no longer there. Where there was that part, you are now writing it as a u. You can find your derivative as normal. Find your derivative for u with respect to x, y with respect to u. Substitute into the formula that represents our function. So this formula here is the one that you are working with, function of a function or chain rule, and you are given this formula on your formula sheet. So what you need is to understand the meaning of your formula. You are given, yes, but you understand what the formula means. If you don't understand, then it means you have to work on more questions, more revisions, like what we have been doing now. I think from this video now, we have got a basic understanding of what is happening on our chain rule or on the function of function. That's it, guys, from Maison African Motives, working on mathematics N4 till we meet again.